Okay. So before moving to know what is orchestration, what is this container, what is the Kubernetes, right? Let's understand the Kubernetes, like whatever things we have learned on Docker side. So what we saw creating the standalone application, standalone containers, one or two containers or individual containers using the Docker. Also, we saw using the Docker Compose how we can use multi-containers, two, three, four containers linked together and start working with complete stack, right? But if you are going to work on multiple containers, more than 10 or more than 100 containers, right? And all the containers, not only the 100 containers or even 5 or 10 containers, if you are going to run in multi-node in Kubernetes, whenever we are going to create the cluster will have multiple nodes. In Docker Compose, what we saw that we run in the single node, right? Single machine. The multi containers were in the single machine, so it is managing. It is quite easy. But when our containers are in different machines and we have a master machine to control all this, that time we need an orchestration. Okay, and Kubernetes is actually a container orchestration platform. Is a container orchestration tool which can help us to orchestrate all the containers and manage all the containers in one place. Okay, so let's start. What is Kubernetes in details? Kubernetes is an open source container orchestration system for automating application deployment, scaling, and management. So Kubernetes is an open source container orchestration. So before Kubernetes actually made to public, it was created and designed and maintained by Google. The Google engineers, they created this Kubernetes for their own project. Okay. Once it is get popular, they made it open source so that all over the world, the engineers, the people can contribute to make it happen. Now, Kubernetes is actually the most popular orchestration platform in the world, right? There are many other orchestration platforms out there. We'll see it. Don't worry. Now, it was originally designed by Google, whatever I said just, and is now maintained by the Cloud Native Computing Foundation. That's called CNCF. Google handed over to the Cloud Native Computing Foundation, and they made it to open source so that everyone can contribute the knowledge and the experience they have to make it better, right? So this is the logo of this Cloud Computing Foundation. Why we need Kubernetes? We got ideas about what is Kubernetes, but why we need Kubernetes? Well, just containers are a good way to bundle and run our application, just before I was discussing, right? So in a production environment, we need to manage the containers that run the applications and ensure that there is no downtime. There is no downtime. So Kubernetes are so popular and so intelligent, and it can also find and sense any downtime or sense any failure, any bug or anything, right? Any error, and it will heal it automatically. In that case, what happens? We make sure there will be no downtime to our applications. Have you ever seen there is any downtime to the Amazon's e-commerce site or any Facebook? Or sometimes there could be very little glitch will be there and it will get slowed down. But you've not never seen downtime, never access that until unless that the entire things goes down. Now it has been more popular in the market. The companies, the organizations are adopting Kubernetes to make their applications, their customers never face any downtime or any issues. For example, if a container goes down, another container needs to start. If you see this diagram here, if there are two containers are there, and suppose one container goes down, it will automatically sense that the container has goes down. It will make another container in that place. Okay. So that's how Kubernetes comes to the rescue. Kubernetes provides us with a framework to run distributed system resiliently. It takes care of scaling and failover for our applications, provides deployment patterns, and more. Kubernetes can easily manage a canary deployment of our system. If our master goes down, what will happen? It will get another master in that place. So this completely, before in the market, there was no such tools or applications or systems available to automatically heal any kind of downtime, right? That Kubernetes can do. Even it's not only any node, even if the master goes down, I'll explain you what is master, what is node in detail with architecture. Don't worry about that. This is just the beginning. Okay. So master or controller, right? What is the master? We'll just discuss it after the slide. Okay. So if the master goes down, it will automatically create another master in that case. So what Kubernetes provides? It provides the service discovery and load balancing. So what is this? Kubernetes can expose a container using the DNS name or using their own IP address. If traffic to a container is high, Kubernetes is able to load balance and distribute the network traffic so that the deployment is stable. That is the benefit, right? If you can see this image, if there are two containers and if there are more customers came and if you get more loads, then Kubernetes, the load balancer will create another container, another pod in between. Okay. Second, the storage orchestration. Kubernetes allows us to automatically mount a storage system for our choice, such as local storage, public cloud provider, and more. These storage systems, right? I was talking about the volume in Docker, if you guys remember, right? The volume, the persistent volume, how you store the data, container data, right? What is the nature of the container? The container, if it goes down, the data, whatever inside the container or deleted, or the data, the container is terminated or deleted, the data, whatever inside the container will also get terminated or deleted. To make it persistent, to make it available, we need a storage system, right? We need a volume to be attached or mounted to the container. That Kubernetes provides the persistent volume and the storage system. We'll see in details about that separate topics to discuss on those areas. Okay. The next will be automatic bin packing. So we provide Kubernetes with a cluster of nodes that it can use to run containerized tasks. We tell Kubernetes how much CPU and memory each container needs. Kubernetes can fit containers into our nodes to make the best use of our resources. So automatic bin packing, right? What we need for our applications, for our containers to run, we can make a configurations file. We can make an information sharing file where we can specify the specifications of the requirement. How much CPU is required, how much memory is required, right? So everything we can see. Don't worry about this piece of code. We are going to see in details and we'll write each code individually. Okay. Next one is automated rollout and rollbacks. That's most important, guys. This is how Kubernetes is most popular, you can say. Automatic rollouts and rollbacks. See, whoever has worked on the production environment, production support, they will mostly know about how crucial, how important a rollback is. So when we go for the rollback, when we go with a release, right, with a deployment, if there is some issues with the deployment or with the release, so what will happen? That particular release fails, then we need immediate rollbacks or rollouts so that with the minimal impact, we can recover our applications or code, right? That is how this is in Kubernetes. The rollout and rollbacks are very easily can be done by Kubernetes itself. So we can describe the desired state of our deployed containers using Kubernetes, and it can change the actual state to the desired state at a controlled rate. For example, we can automate Kubernetes to create new containers for our deployment, remove existing containers, and adapt all the resources to the new container. So whenever we are going to deploy the release, that means we have to first remove the existing one, then deploy the new one, right? So when we execute this Kubernetes command for a deployment, what it will do? It will first create a new container and then remove the existing container. That means the customer will never see a downtime, because see, first what it does, first it creates, then it removes. So when it creates, the system will be available for the customers to use. Then it removes the older version. If it finds there is any issues, right? If you see this diagram here, up suppose 1.1 are there, what it will do? We are going to deploy app 2.0. So what it will do? First, it will deploy and then it will remove one. Again, it will deploy one and remove one. This is how it does. If suppose we got some issues in app 2.0, so what it will do? It will automatically roll back to the previous one. We'll see in details how it can be done. And that's most important also for you to understand. Okay. Now let's move on. So the next will be self-healing. That is what in the initially I was talking about, right? It has the capable of self-healing. What is this self-healing? If you see, if you can see here container or pod is there, right? Kubernetes restarts containers that fail, replace containers, kills containers that don't respond to our user-defined health check, and does not advertise them to clients until they are ready to serve. Just try to understand this statement, whatever is written. What it says, Kubernetes restarts containers that fails. If it finds any container fails or any container needs to be replaced or kills, it will automatically kill that one and create another containers in that place unless it goes off. It will not publish it to the customer. That means there will be health check who will be providing the health check to make sure the containers are up and running and is now ready to be customer to be accessed. Then only it will publish that one to the customer. There, the customers will not face any downtime or any slowness, right? That's the self-healing. Now, so if you see this diagram, if it is gets red, right, then what it will do? It will get another container in that place. That is what it means self-healing. The sixth one is the secret and configuration management. See, in the IT industry, right, in the software industry, what we need, the secrecy is most important, right? Why we need the secrecy? Secrecy of what, right? What we need? Our confidential informations. So what are the confidential informations? Like the user ID, the password, the DB informations, the DB server, right? All these are most crucial and it should be kept as secret, right? These are the sensitive informations, right? So Kubernetes provides that feature to make it secret by using the secret and configuration management. So Kubernetes, it lets us store and manage sensitive information such as password, authentication token, SSH keys, right? All these things. So this is what provides. Now, what is the importance? Let's see, what is the importance of container orchestration? Container orchestration can be used to perform a lot of tasks. Let's see, what are the tasks? One is the provisioning and deployment of containers. Next one is scaling of or removing containers to spread application load evenly, right? provisioning and deployment of containers, scaling up and removing containers to spread application load evenly, movement of containers from one host to another if there is shortage of resources, movement of containers from one host to another, means from one node to another. Just try to understand this one time. Means if you have a cluster, Kubernetes cluster, having three nodes, one master and three nodes. If your containers, whatever you are going to create based on the configurations or based on the automations you have written, and the container has kept almost all the nodes, whatever we have, all we lost our resources. We don't have enough resources for the new container to be created, right? So what Kubernetes will do, based on the configurations we do have set up, it will create the containers in another node. If it finds any kind of shortage of resources, it will keep those containers in another node. Load balancing and service discovery between containers. Load balancing and service discovery between the containers. The next one is the health monitoring of containers and clusters. That's most important, with which it takes all actions because it does the health check very frequently. Within every second, every milliseconds, it does the health check. When we understand the architecture, the complete flow, you will understand how the Kubernetes works. Okay. So container orchestration solutions. As I said, Kubernetes is the most widely and popular orchestration solutions and provider being used in the current market. What else are there? First, Kubernetes. Other one will be the Docker Swarm. The Docker Swarm is the native to the Docker. Okay, but Kubernetes has taken the market. The meshes, Apache meshes, is also an orchestration platform. There will be EKS, right? Imagine EKS, Elastic Kubernetes Services. There are many more, guys. I just listed out 4. There are many more. Even Google Cloud has, even Azure Cloud has, right? Azure has Azure Kubernetes Services, AKS. Google has also, right? All they have their own services with them, and these are the managed services. Okay. Now, so let's see this particular diagram. What is this container orchestration is all about managing the life cycle of a container, of containers. Suppose we have 3 virtual machines, 3 nodes. In these 3 nodes, we have 3 containers are there. So if this particular web server container has goes down and don't have enough resources available, what it will do, it will create that in another node. So here VM1, VM2, VM3 are nothing but the machines, different machines or different nodes. Okay. So where does the Kubernetes live? You need to understand this also carefully. Kubernetes, we can do it anywhere, in development platform, in testing platform, okay, in deployment, in productions, everything. So for the training and R&D purposes, to learn, right, to do the R&D, to do POC, what do we do? We can go with Minikube. So Minikube is a cluster, local cluster being provided by Kubernetes, and it is actually one master node cluster. That means it has only one server, which being treated as the master as well as node. Master as well as node. So that is the one cluster node, one cluster Minikube, right? So another, they use development platform. We can go with Minikube. Most of the companies, they use Minikube because cluster is not so good if you're going with development and all, because it is expensive, guys. If you're going with cluster, right? When we talk about the cluster, it will not only one server, it will be having more than one server, right? So when we are getting 1 or 2 servers, 2 or 3 servers, then we have to pay accordingly. For development purpose, it's not required. So we can go with Minikube or Dev cluster for cloud things. But for deployment things in productions, Minikube will not work, because deployment we are not going to do in single cluster, right? Single machine cluster. In single machines, deployment never done. We never do it. Right? So we go with different tools called Kubernetes, K8s, cloud provider, and bare metal. We'll see. I'll just guide you how we can do using K8s and Kubernetes. So, and in details after the Kubernetes, once we complete the entire Kubernetes part, then we go with the uh, cluster part, how we can create using Kubernetes and K8s. First, let's go with Kubernetes with Minikube. Okay. Before we are going to do that, let's understand the architecture. We were talking about the masters and all, right? I was talking about the master node and all. How the health check is being performed by Kubernetes, how the monitoring happens in the Kubernetes, right? Let's see in details. We have different other tools for Kubernetes like Kivana, Prometheus, right? Some other tools, Helm chart, and all the other tools, advanced tools are there that I'm not going to cover in this class today, because Kubernetes itself is a huge topic, and I'm going to cover it within 2 to 3 weeks, within 2 weeks of time, right? Within 4 to 5 classes, I'm going to cover it. So, and okay, and as I said, the monitoring solutions, we're not going to see it, but here how the health check is being provided. Let's the complete flow, the complete architecture, let's understand. So here, if you see the diagram, right, I have one cluster having one master and one node. I have one master and one node. So if you see this diagram, we have this kubectl. It's called kubectl or kube control. It's up to you how you spell it. It's called kubectl or kube control. What is this? This is the client. This is the CLI, command line interface, through which we are going to send request to the master. Let's see the flow, how it is looks like, right? So the kubectl sends request to the API server. The master contains the API server, the etcd database, the scheduler, the controller. Let's understand each part in depth. Okay. So what happens here? When the client sends request, right? When the request comes from the client, from the kube control, what happens here? The API server receives it, and then the API server scans the etcd database within the seconds, immediately. If it finds whatever things gets requested by this one, what happens? The etcd database scans, and then it gets the response back from etcd database, and then it sends the instructions back to the scheduler. Then what will do the scheduler? The scheduler will send back the information to the API server. Then the API server sends request back to the node through kube proxy, and the node contains kube proxy kubelet, the agent who takes care of the request gets from the master, and the Docker daemon who creates everything, the runtime environment or the Docker daemon. Okay. So once the request comes from API server to kube proxy sends request to kubelet. Then what happens? Kubelet gives instructions to the Docker daemon to take actions on the pod A, pod B, or whatever things to be created. This is how the architecture, this complete things work. Then you'll be thinking what this controller does. Whatever the request, we got it through API server, it from client, from kubectl, from client to API server, it goes and scans the etcd database, get the details, and sends request to the scheduler, gets the response back, and sends to kube proxy to the node, and then kubelet instructs to Docker daemon. Then Docker daemon takes care of everything. So what is the role of this controller here? Actually, The controller is the brain behind everything. The controller is the brain behind everything. What it does, it keeps doing the health check actually. It does the scanning every milliseconds. It will be doing the scanning of the etcd database. Okay. Then what happens? It keeps scans, find if it finds anything needs to be noticed or needs to be performed or needs to be rectified. It finds anything abnormal or anything failed, then immediately it notify to the scheduler. Immediately it sends request to the scheduler. Then this pod is down. Go ahead and run it again. So scheduler, what will do? Scheduler takes decisions where it to be created. Then it sends request through API server. It goes to the node, which node scheduler will decide. Then it will send back to that particular node, and it will okay. And all the informations, where the container is, where the pod is, right? Which node, which machine, what particular details, what environment, okay? Which workspace, everything will get the details from the etcd database. Okay, and the controller sends all the information to the scheduler. Then scheduler gets everything, sends everything to the particular node based on the information available in the database. Okay, this is how Kubernetes makes sure that the pods or the applications or the container are all the time available. It never goes down. It does the self-healing, right? Let's understand in details about the architecture. This is what I just discussed you, right? This is whatever is written, the flow I just told you. I'm not going to read it again. Now let's understand the services. So during the Kubernetes installations, these following gets installed: API server, etcd, scheduler, controller, kubelet service, kubeproxy, and container runtime or container daemon. If you see this diagram, when you install, all these things will get created: API server, scheduler, etcd database, controller, and kubeproxy, kubelet, Docker daemon, or Docker runtime. Okay, I'm not going to read the flow, whatever I just explained to you. Let's see. Each details what the API server does. As I said, the API server receives the request from the control. But what extra it does? The API server acts as the front end for Kubernetes. The users, management devices, command and interface all talk to the API server to interact with the Kubernetes cluster. That is what I was talking, right? The command line, the client will interact with the API server. So any request comes from the client, the API server will receive it and takes it back to everywhere, right? The next would be the etcd. So it is a distributed reliable key value store used by Kubernetes to store all data used to manage the cluster. Everything, right? When a cluster goes down, when a cluster created, where it is created, what has changed, what the color, everything get updated into the etcd database. It is a flat file database, so you can say key value pair database. All the data are maintained in the etcd database, right? So that is when we have multiple nodes and multiple master in our cluster, etcd stores all that information on all nodes in the cluster in a distributed manner. Okay, everything gets stored inside the etcd. That's why the controllers, it never checks if there are multiple nodes. Then controller will not go to every node and check it, right? Where it will check, it will directly check in the etcd database and it will be done. Then the scheduler. So the scheduler is the man who does the actual work. The scheduler is responsible for distributing work or containers across multiple nodes. It looks for newly created containers and assigns them to the nodes. Okay, this is what it does. Then what the controller does, as I was saying, like the controllers are the brain behind the orchestration. They're responsible for noticing and responding when nodes, containers, and endpoints goes down. The controllers makes decisions to bring up new containers in such cases, right? Let's see the container runtime. What is this container runtime or daemon? It's the underlying software that is used to run containers. It's actually the container runtime or daemon who takes care creating and destroying the containers. In our case, it happens to be Docker. So we are using Docker daemon, right? So kubelet, we saw one small icon there, kubelet, right? The kubelet is the actual agent at the node side, right? So kubelet agent that runs on each node in the cluster. We have 5 nodes, means we'll have 5 agents in the 5 different clusters. The agent is responsible for making sure that containers are running and on the nodes as expected. The agent is responsible for making sure that the containers are running on the nodes as expected. Okay, so kubeproxy, it takes care of the networking with Kubernetes. Okay, so that is what the total architecture of the Kubernetes. So in our architecture, what we saw, Kubernetes, the etcd database was in the master, in the single in the architecture, right? We saw the master, we had this etcd database where in the master itself. If you see this stacked topology, I'm just going to explain the 2 kind of topologies. When the stacked topologies, where we'll have multiple masters, and each master will have separate etcd databases, separate etcd database, and it will be synced through the concepts being used. Okay, but here in the stack topology, what we'll have, we have separate etcd databases. If you talk about the external etcd topology, we have stack topology where we have etcd in the separate master machine. It's called master, or remember, controller. Okay, master or controller. You may get questions in the interview. They may ask you what is the role of controller. If you not understand what is the controller, then they may think like you don't know anything, right? So master, which is nothing but the controller. Okay. So here in the external etcd topology, what is happened here? The etcd topology here are actually, the databases are not kept in the machines, any machines. It will be kept in a different server and different machines outside of the cluster or outside of the master. And those are automatically, all the data, whatever through this master, will be linked or worked together into the databases. If you see the diagram. Now from the diagram, you can understand, right? What is the benefit here? If one, okay, let's talk about this. What happens here? We have this etcd here and we have this etcd here. If the master goes down, if any newly created things will not be updated here, right? If this master goes down, this master will take care, right? But the newly created, if this particular master one has created this something new and some changes, it will not be reflected here, but some problem, right? Stack topology. But here in external etcd, what will happen? Everything's get retained to the outside of this database. So that what will happen? Anything goes down, the other master can take care from there because everything will be up to date, right? Okay, guys. So that's all about to the master and external topologies and whatever talks we did about the Kubernetes and the architecture we discussed. Now, okay, so far any doubt, guys, anything you need to know more? I think it's very clear whatever I just explained you, right? Do you have any doubt or anything know further? Just let me know, or else we can go ahead and create our first cluster to do the demo, right?
Sir, in this case, suppose the other user, means the kubectl client, suppose try to create any pod, then which master will take care of this?
Okay. So that's a good question. So you can see here one load balancer will there, right? So load balancer based on the setup you have done. So you don't think that all the masters will be working here. If one master is working, the other master will be ideal. It will be sitting there. It will be like standby. Not all the masters will be working together. It will be standby. If this particular master goes down, right? If this particular master goes down, suppose this particular master goes down, right? Then what will happen? This master will take care of the work. What will happen here? It will get the data available here from the etcd database. Don't think that all the masters will be working together. No, one will be ideal, one will be working. That's why the load balancer will be there. We will take care of it. Okay, is it clear?
Yes, sir.
I have one doubt.
Yes.
Usually when we install YouTube, it will have only one master. Right? So
Sorry.
if you want to, usually if we install a YouTube on a laptop, it will have only one master, correct?
No, see that is what. If you are installing the Kubernetes cluster, right? If you are going with Minikube, then it will be one master and one node. Only one node. That node will be your master as well as node. If you are working with Minikube, if you are installing, see that is why most of the companies, right? They have multiple masters and multiple nodes. They create their own cluster using kubeadm or KOPs. By there, you have to specify how many masters do you need and how many nodes you need to add it into the cluster. So the cluster, as I said, could be one or more, could be more than one machine should be there in a cluster. When we say cluster, it will be more than one machines, right? So companies will have multiple nodes, but if you are using Minikube, it will have only one master, and if that goes down, then nothing can be done. You have to restart it again manually. It cannot be. Kubernetes cannot do anything. This is only a single machine, right? If a machine goes down, then it is required manual interventions to start that master, right? Is it clear? Okay, guys. So let's move on and start deploy the. Let me just remove out all this. Let's start deploying. Start installing the Kubernetes. Okay. So to install Kubernetes, right? Let's go ahead. So we have this Kubernetes. I'm going to set up in the Ubuntu 20.4. Okay. For that, let me just get to the server. 1 second. Let's log into the. Just hold on. Let me just get created everything. Okay, I'm quickly going there and creating one server here. Let's go and launch instance. So I'll go with Ubuntu, suppose 20.4. Okay. Based on a requirement, you have to select it. So let me just understand the requirement here, not this one. Okay. So the requirement, system requirement to install this Minikube and all, what we need, minimum 2 CPUs or more. Okay, minimum 2 CPUs or more. 2 GB of free memory, 20 gigabyte of free disk space, good internet connections, obviously, and container or virtual machines. Okay, for that, we're going to get the Linux machines. We have to install the Docker first and then install the Minikube local cluster setup. Okay, then we'll install the kubectl. Step by step, everything what we are going to do. Now, let's go ahead first make our server ready, make our machine ready, right? T2 micro. So for what we need minimum 2 CPU. But T2 micro, what is having? Having 1 CPU and 1 gigabyte of memory. What the requirement is? The requirement is 2 CPUs and minimum of 2 CPUs and 2 gigabyte of memory and 20 gigabyte of free disk space. So guys, whenever you're going to use this in AWS cloud, it will not be free. It will charge you. Okay. So be careful whenever you are doing practice. Make sure you create it, do practice, and delete it immediately. The server, whatever you create, they will charge you based on the hourly basis, right? Let's see. For that, what instance type I should select? The free tier will not be eligible because it has only in CPU. So I should go with T2 small is 1 CPU and 2 gigabyte memory. This will also not, it will slow down the cluster, right? Machine. So I should go with T2 medium. T2 medium has 2 virtual CPU and 4 gigabyte of memory, right? And it charges, the Linux pricing is 0.0496 USD per hour. Suppose you are practicing for 1 hour, that's okay. You have to pay very minimal, right? Only few rupees, and how much it will be? One, 2 or 3 rupees, 3 or 4 rupees, or 30 rupees, something like this, right? Let's convert it, right? What was the price? Sorry. Let's select T2 medium, right? The price was, Linux price was 0.0496. 0.0496 USD to INR. So 4.09. So 4 rupees per hour you have to pay. That's okay. So you can at least pay some minimal to work on your things, right? You can do the practices. You can do the practices by just paying some minimal, right? So you can, and then once you do practice, make sure that you delete that immediately, right? Don't keep it running, or else you have to pay for that, right? So let's go ahead, select the key, and the rest of the things let it be there, and memory. So minimum 20 gigabyte is equal. So let it be 30 gigabyte of memory. So not memory, storage. Okay, the storage is 30 gigabyte. Let's go ahead and launch instance. Okay, let's see. So it is pending. Just be with me for a few seconds. Let it be run. Okay. Okay, so it seems running now. Let's refresh for a few seconds. Okay, let's get the IP address and try to log in. If I just go here, we terminate this and create a new one. Waiting. As this is Ubuntu machine, the user ID will be Ubuntu, right? Ubuntu @ get the IP address, public IP, enter. Yes. Good. Now I just connected to the machine, right? I just connected to the machine, Ubuntu machines. Now let's make this server as my Kubernetes cluster, right? So there are a few installation steps I'll just share with you. You need to execute it. So as we know, right? First, when we get our server, first what we need this to be updated first, right? Let's do update sudo and apt-get or apt. You can use package manager apt. Remember, for Ubuntu, the package manager is apt, or you can just use apt-get, apt-get. Okay, object. For CentOS, for Amazon Linux, the package manager is yum, right? The package manager is yum. Object yes. You can check if there are anything. Yes, lots of things that are going to get updated. Just hold on for a few seconds. Yeah, it's done. Now, what we need after we update these things, we need to install Docker, right? We need to install Docker. Let's install Docker first. Let's clear it out. Install Docker. Installation is in progress. 36, 40, 45. Yeah. Why you need Docker? We need the Docker daemon, right? As I said, we need the runtime. So we need to install the Docker. The containers, everything is going to be created by the Docker daemon, right? So just wait. It's progressing now. Okay. Okay, so it's done now. The next, what we need to do, we need to install the minikube. After installations of Docker, we need to install the minikube. Let's execute this one. So what this command will do, it will, using the wget command, right? We are downloading these executables first. We are downloading. So this minikube is now downloaded. What we need then, we have to copy this particular things. What we did, we just copy this whatever things we downloaded to the user local bin and renamed it as minikube. Renamed it as minikube, right? What we did do next after that, because it will not be executables, right? We need this to be executed as executable. Make it as executable. That means we'll give it as XXX there, right? XXX. Then it will be executable. Now, okay. So once it is done, we added into the bin locker. If I do mini cube version, so this is the minikube version 1.30, and this is the commit ID. Okay, so this minikube is installed successfully. Now what you can do, install the client. So when we created the cluster now, right? We created the cluster. So during the installations, we'll have the API server created. We'll have the kube. We'll have the etcd. We'll have the scheduler. We'll have the controller, right? All these things. We'll have the kubelet. Or we'll have Docker daemon we installed, right? All these things will be created. Now what we need install the client. The kubectl, the kube control need to be installed. So here I'm using call command to download the kubectl executable, kubectl tool, right? So this tool is now downloaded, right? So let's change, give permissions to it. If I just give here, so this kubectl is downloaded, but it does not have executable permissions, right? Let's provide executable permissions, having giving chmod So if I do ls hyphen l now, see we have now triple x added, right? X here, x add. User having executable, group as executable, others having executables. Okay. Now what do we do? Let's move it to user local bin so that globally it will be available. Use. Now kubectl is added. If I do kubectl version, so what it says, this version information is deprecated, that's fine. Okay. The connections to the local server 8080 was refused. Did you specify the right host or port? Guys, remember while creating, we did not specify any security group, so it took default one, which is having only 22. So let me change this particular security group, right, of this server. What I'll do, I can go here, network settings, no, instance settings, and change security groups. No, security, yeah, security. You have to go to the change security group here, and I have only this one, right? Let's remove this one. I don't need. Let's select this one, which is having the required port. You need to select at least one security group. Yeah, I selected that one, right? We have to add security group. So added this lamp SG. Now save. Okay. So if I go to the security group of this particular one, go to the security. Here, see, I have this 8080 port. Rest of other ports are there. May not required, but let it be there. 8080, all these things are there. So now if I go here, this there, right? Even though I just added, I do version check, it will still refuse. It's because the daemon will not be working, right? So everything I've written here. Let's go to that. So for that, before checking this kubectl, let's do the kubectl, start the kubectl. Okay. To start the kubectl, what we have to do first, we have to make sure we created the Docker group here. Okay. So what I have to do, use this command to add this into the sudo format, right? User adding. Now let's start the kubectl, minikube start. Before that, let's make sure the Docker is it starting or not. So system ctl status Docker. Yes, Docker is running. Then it's fine. The daemon is running. Okay. Now let's start the minikube. So it's very simple to start the minikube. It will be minikube start. Simple command, minikube start. Hit enter. See, and make sure before that the Docker driver and Docker it is active and running. Otherwise, it will not work. Minikube start. Just wait for a few seconds. Okay, it's downloading and making sure all the required things to be done. Okay. I'm just going to paste all the command whatever I just executed so that you can just keep it handy and make sure that keep these commands whatever I just pasted in the chat. Okay, so keep it and just try to get all these things installed and try do practice. Okay, just wait for a few seconds. It's still taking time to download the cluster and making all these things. See, downloading it when we start the minikube start, right? We just downloaded the minikube executables, but when we do minikube start, it will start downloading the Kubernetes and do all kind of installations. Okay, we are doing this. So what it says, let's see here. The minikube, this particular 1.30.1 version, using Docker driver, the Docker daemon, right? With root privilege, starting control plane node minikube in cluster minikube. Control plane is nothing but your master, right? Starting the master or the control plane. Okay. So here downloading the Kubernetes is downloaded the Kubernetes, and these are the things, the version, the sizes and all these things downloaded. After that, creating Docker container with CPU 2 and memory 2200 MB. It's 2 gigabytes, right? Just wait for a few more seconds. Preparing Kubernetes. Done. Booting of control plane. So it is starting the master now. See, it's done now, right? Done. kubectl is now configured and use minikube cluster. Now, if we do kubectl version, see, it gives us the version details. It's not giving any errors, right? Let's execute some commands there to check it out, right? We got the start, we started. Let's check the status, minikube status. It will give us the details. See, the type control plane or the master, host running, kubelet running, API server is running, kube config, it is configured. All the status it gives, right? Cluster informations, if you want to get, you can use kubectl command now. kubectl, the client command to get informations on the cluster. So you have to use kubectl cluster info. What it says? The core DNS is running here. To further debug, so okay. So the core DNS is running here, right? Let's copy this one and check whether we can able to access this or not. Will not have access because this port is not whitelisted. Okay, let it be there. So it's running now. Let's check the how many nodes we have. What we can do, you can use kubectl get nodes. See, we have only one node, minikube. Ready, status is ready. To control, and 2 minutes 4 seconds ago it is created the version. Okay, there are many other commands, kubectl commands we are going to learn slowly side by side, where there are many other topics are there to discuss, right? All these things we are going to learn in our upcoming classes. So far, whatever we covered about the Kubernetes, the architecture and the installations, I hope you guys understood everything clearly. Just do practice whatever we have covered in today's classes. From next classes, we'll discuss more the Kubernetes object and we'll go in with all the commands and all the labs. We'll see all the developments. That's all, guys, for today's class. We can meet up next weekend, same time, 8 a.m.